This video tutorial is going to cover calibration and graduated cylinders, both concepts that need to be introduced at the very beginning of any science class, especially chemistry, because we're going to be using calibration and graduated cylinders and beakers and different measuring devices throughout this course. So let's start off by defining calibration. What is calibration? That's going to be a key thing we need to know. This is a key vocab word. So calibration. Calibration is the value of each marking on any measuring device. For example, if we look at this graduated cylinder right here, we see that it only has 3 of the many lines on here labeled. We have 100, we have 200, and we have 300. What we want to know in terms of calibration, if I asked you what the calibration of this graduated cylinder is, it represents the value of each one of these small markings. So how do you figure out the calibration? Well, you look at the graduated cylinder and you look at 2 of the labeled lines. So we have 100 right here and we have 200 right here. Then you count how many lines, typically it's going to be 10, how many markings are in between each of our measurements. So we have 100 and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So typically it is going to be 10. It'll change every once in a while, like this one down here is a little bit different, but you count the lines between your 2 labels on your markings. So we have 10 different markings between 100 and 200. Well, how big of a difference do we have between 100 and 200? We're going up by 100 in total value. If we have 10 lines, then we just need to divide the difference of 200 and 100 by the number of markings that we have. So in this situation, from 100 to 200, that's an increase of 100 milliliters, which means we have to do 100 divided by 10, 100 divided by 10 in the calculator, and you get 10. That means the calibration of this device right here would be 10. So the calibration here would be 10, and if it was measured in milliliters, the calibration of this device right here would be 10 milliliters. I would recommend drawing this and then labeling that each marking is worth 10 milliliters because we're going from 100, this would be 110, 120, 130, 140, 150, 160, 170, 180, 190, and 200. And I got that just by counting each of the lines and then dividing that number by the difference between 100 and 200. Let's look down at our other graduated cylinder right here. This one's a little bit more difficult to see. You can see that we have one line labeled 5, then 10, 15, 20, and 25. If you were able to count these small markings in between these values, you would see that there are 5 markings between each labeled value. So between 5 and 10, there are 5 markings. Between 10 and 15, there are 5 markings. So between 5 and 10, what is the difference between 5 and 10? It's 5. If there are 5 markings between 5 and 10, and the difference is 5, you would just do 5 divided by 5, which gives you 1, which means each marking here is worth exactly 1 milliliter. So that is all calibration is simply the value of each marking in any measuring device. So up here we had a calibration of 10 milliliters. Down here we have a calibration of 1 milliliter, just the value of each marking. So that's all we have for calibration. Now on to graduated cylinders specifically. We're going to use graduated cylinders a lot to measure different things like density and a few other aspects of chemistry. So we need to know how to read a graduated cylinder. So that's why I'm going to draw your attention to this excellent image right here first. So you see this scientist right here, he's trying to measure some amount of liquid in his graduated cylinder, and for some reason he's down and he's looking on an even plane with the liquid. He's not looking above it, he's not looking up at it, he's looking even with the line. So the liquid would end right here, you'll see that's right in line with his eyes. In order to properly measure the amount of liquid you've put in a graduated cylinder, you have to get down on an equal plane with wherever the liquid ends. So you can see right here, he's got it about 10 milliliters, but to find out exactly how much is in there and get the appropriate measurement, you have to get down and actually visibly look on an even plane with that liquid to tell how many milliliters or liters are actually in that graduated cylinder. So that's step 1. Step 2, whenever you pour liquid in a graduated cylinder, it's going to end up looking just like this. There's going to be a little bit of a crest right there. Where do we measure from? Well, it's important to note you always, always, always measure from right here, from the cusp of the crest right here. You always measure down at the bottom. So I would draw these in your notebook, and I would circle right here or put a line right here. That is where you are going to measure. So for example, this graduated cylinder right here, if you looked at the top, you would say it had 38 milliliters. But if you look at where the line actually ends, it's got about 36.5 milliliters. So you always look right here at the bottommost point of that crest, and that is how you appropriately measure the amount of liquid in a graduated cylinder. So this one has about 36.5 milliliters of liquid in it. And its calibration, by the way, what would its calibration be? It would be 5, because we have a difference between 35 and 40, and there are 5 lines in between. So 36, 37, 38, 39, and 40. Okay, we look at this one. Same thing. You measure at the bottom. You measure at the bottom part of this crest right here. So you have 70 right here. We know the calibration. They're each worth 1 because it goes from 70 to 80, and there's 2 lines. So we have 71, 72, and 73. So this would have a measurement total of 73. So reading graduated cylinders is pretty straightforward. You just got to look at that bottom cusp right here, the lowest point of the water or of the liquid. And when you look at it, you have to get down and get on an even plane with that liquid. All right, last thing, measuring density with a graduated cylinder. So we're going to go over density throughout our first unit, and we're going to use a graduated cylinder to measure that density. The process of measuring density with a graduated cylinder is called water, I'll bold this, water displacement. What water displacement represents is you have a certain amount of liquid. We're going to look at this visual example right here. You see that right now we have about 3.4 milliliters of water right here. As soon as this odd-looking blue fellow right here jumps in the water, you'll see that the amount of water increases to 5 milliliters. Just like if you ever get in a swimming pool, if you see a swimming pool before it opens, it'll be at a certain level, and then a whole bunch of people will get in it, and the level of the water will rise. It will actually get higher. The reason for that is because anything that gets in a liquid is taking up a certain amount of space or has a certain density. So the density of this man right here, if we were at 3.4 milliliters, and then he gets in the water and we go up to 5, would be 1.6 milliliters. So you measure water displacement. It is the, unbold that, the difference in water level from once putting the object into the water. So it's the difference in water level once you put the object into the water. So right here it was 3.4. It raises up to 5. So what I mean by the difference is you'd have to do 5 minus 3.4. You end up with a density of 1.6 milliliters. So that would be the density of this man. Same thing here. We'll just say that this is a measurement of 50 milliliters right here, and it goes up to 100. As soon as you put the block in the water, you'll see that the water rises up to 100 milliliters. You just calculate the difference, 100 minus 50. The density of this block would be 50. So water displacement is just a difference in water level once you put the object into the water. So you can see that here, how it rises up. You just do 5 minus 3.4. So that is how you measure density with a graduated cylinder. We'll do that a few times throughout the semester. It'll be better when you can actually see it in person. Anywho, that's graduated cylinders and density. Good luck and farewell.